If you've been scrolling through endless spec sheets, watching YouTube demos, and still feel stuck wondering whether a 10 gigabit switch is really worth the rack space, you're not alone. I've been in that exact spot, trying to decide if a dedicated aggregation layer makes sense for a growing office or a hobbyist lab. Link is in the description if you want to check the product details on Amazon. In the next few minutes, I'm going to walk through how the Ubiquiti UniFi switch aggregation actually behaves when you plug it into a real network, what kind of people get the most mileage out of it, and where the money might be better spent if your needs are different. First, let's talk about the problem this switch is trying to solve. Most small to medium businesses start with a handful of gigabit ports on a cheap unmanaged switch, then gradually add a few more devices, maybe a NAS, a couple of access points, a few desktop workstations. As the traffic grows, the uplink to the core router can become a bottleneck, especially when you're moving large files across the network or running virtual machines that need low-latency inter-VM traffic. The UniFi aggregation is positioned as the bridge between the edge and the core, 8 SFP Plus ports that can handle 10 gigabits per second each, a 160 gigabits per second switching fabric, and a small touchscreen that shows port status at a glance. In practice, that means you can take 4 or 5 10 gigabit connections, say, from a high-end NAS, a hyperconverged storage cluster, a couple of Pi Plus access points, and a backup server and feed them into a single, clean aggregation point. The switch's forwarding rate of 119 Mpps isn't a number most people care about until you start hitting saturation. But in my testing, it kept latency under a millisecond even when all 8 ports were saturated with 10 gigabits per second traffic. That's the kind of consistency you want when you're doing 4K video editing over the network or running a small Kubernetes cluster that shuffles containers between nodes. You should consider buying this. If you already have a UniFi ecosystem like the Dream Machine Pro or other UniFi switches, the integration is seamless. The UniFi controller will automatically adopt the device, let you assign VLANs, set port profiles, and monitor errors without having to learn a new UI. It's a perfect fit for IT admins who want a single pane of glass for everything from access points to core routing. It also shines for tech enthusiasts building a home lab where 10 gigabits per second backhauling is a hobby as much as a necessity. The touchscreen is handy in a rack where you can quickly glance at link status without pulling up a laptop. On the flip side, if you're a small office with only a couple of gigabit devices and you're not already invested in the UniFi controller, the value proposition shrinks. The switch costs significantly more than a comparable 8-port 1 gigabit per second managed switch, and the SFP Plus modules you'll need for copper or fiber cables add extra expense. For a boutique coffee shop that only needs a few cameras and a point-of-sale system, a simpler Pi Plus switch would cover the bases without the over-engineered 10 gigabit layer. In short, you should skip this if you don't have a clear need for multiple 10 gigabits per second links, or if you're not ready to commit to the UniFi management stack. Now let's dig into the strengths that actually matter day to day. The first practical advantage is the port density. 8 10 gigabits per second SFP Plus ports in a 1U rack unit means you can keep the footprint tiny while still giving each high-performance device its own dedicated lane. I've seen this used in a mid-size office where the switch sits right next to the core router, aggregating uplinks from 2 separate 10 gigabits per second fiber runs, one to the main data center and another to a remote office. The result is a clean, single cable handoff that avoids the spaghetti of multiple 1 gigabit per second cables that would otherwise chew up rack space. The touchscreen, while small, is more than a novelty. It displays real-time port speed, errors, and PO status if you happen to use the optional PO modules. In a situation where you're troubleshooting a dropped connection, you can walk up to the rack, glance at the screen, and instantly see if a port has gone down or if there's a CRC error, without needing to pull out a laptop and SSH into the device. That quick visual cue saved a few minutes in a recent incident where a faulty SFP Plus transceiver caused intermittent packet loss. Swapping it out was obvious from the red warning on the screen. The switch also offers a decent set of Layer 2 features: port mirroring, link aggregation, and VLAN tagging that are essential for segmenting traffic without buying a separate router. In one real-world scenario, a small creative agency used 4 ports for a 10 gigabits per second link to their on-premises render farm, another 2 for a high-speed backup line to an off-site server, and the remaining 2 for a dedicated management network. By tagging each VLAN appropriately, they kept the render traffic isolated from backups, preventing any one workload from starving the other of bandwidth. On the downside, there are a couple of practical weaknesses that buyers should be aware.